Hi all. So in this lecture, we are going to learn about how we can insert a node at the beginning of the linked list. Like we have a single linked list we are currently dealing with, and we have to insert a node at the beginning of the linked list. So let's take our original linked list. Let's say it's 200. This node points to another node with address 200. Then there is a data 20 at here, and this node is pointing to another node with the address 300. Then we have a data 30 here, and then there is an address of the next node which is 400, and then there is a fourth node with the data 40, and it is not pointing to any other node. That is, it is the last node, and that is why it contains null. And then we have this head pointer pointing to our the very first node. Okay, so now the thing is that we have to insert, the requirement is to insert a new node with the data, let's say 50, uh, at the very starting of the linked list. Okay, so this is called insertion at beginning. Okay, so we need to write a function. The linked list is already provided to us. We need not to recreate it again. So we just have to insert a new node at the beginning of this linked list. So we need to write a function for that. So let's create. It will be similar to the create function that we have already discussed, but unlike that, we just have to insert at the beginning. So we will be more focused on that. Okay. So let's say our function is void insert at begin. Okay. And like I told you, we for every function we need to have the reference pointer, that is the head pointer, okay, so as we can reference to the link list, right? Now we have to insert a new node. So definitely we need to create a new node first, and we have to insert it. So let's say we have this node as, okay, one more thing, we can write it as struct node, and then the pointer as a temp. This is just a node pointer so that we can have the temporary value in it. And this is a node pointer, definitely. Now we have to create this node first. So this creating this node will be done with the malloc function in C. So it will be node pointer malloc, and then size of this O should be capital, size of node. Okay, so this way we can create a node temp, and of course this node creation will be done beforehand. So this is a node pointer, and its name is temp. So inside the temp, we already created the space for that by allocating some size, right? Now we will be placing temp next as null. So this will be null. So this is our temp pointer, sorry, temp node. We have allocated some memory space. Let's say its address is 500 or whatever. This is just a random one I have picked up. So this is a particular memory allocation done with this statement temp equal to node pointer malloc size of node. Okay, and then we have provided the null pointer value in the address field. And now it's time to take the data from the user. So let's printf enter data element, and then we have the scanner for taking up the data percent is d, and we are taking the data in data of temp. So that's how we have taken the data, sorry, this is address of. That's how we have taken the data as 50, right? Now we have the node ready. Now the thing is we need to do the pointer adjustment. That is important. So we have the head pointer. So what we'll do here, the logic is inside the head, we are having this 100 address, right? So we have to put this temp here. So for that, we need to update the address of the head here like 100 so that it will point to this, and this address we need to put it here like 500. Okay, so this head will now point to this node and this connection will be broken, right? So for this, what we'll do, we will place also we need to check if the linked list is already empty or not. Why? Because if there are no nodes, if head equal to null, if there are no nodes, then definitely head will contain null. So in that case, we can simply put the value we can simply put the temp value into the head, okay, the address of temp into the head, right? That is why, we have, when we are creating the node, we have taken it as pointer, node pointer head. Okay, this is a temp is just a pointer containing the address of the node. Okay, and then we have allocated space for that, and then we have put the next and so on and so forth. Okay, so this contains the address. So now we have just put the address of temp into the head. Else we have a list, then definitely we have to put the head value into the temp. Okay, and then inside the head we need to put the temp value so that the head points to the newly created node. And of course, we have the temp setting to null because this is required because this temp is a pointer pointing to the newly created memory space. Okay, and then we'll come out of this, and then all okay, now we have this new node attached at the beginning, and this head is pointing up to this new node. Okay, so this might be a little bit confusing. I'll illustrate it once again. So let's see this works or not. So this is our linked list. Okay, let's say we have three nodes for convenience. Now this is at address 100, this is at address 200, this is at address 300, and this is the last, so this is null. This points to this and this points to this. Okay, 10, 20, 30, these are the values. Now we have this head. Head is simply a node pointer containing the address of this. Now let's say we need to create a new node. Okay, we need the create to new node. So definitely for that, we have to allocate some memory space with the address. Let's say the space with 500 is available. Okay, so what we'll do, we will create a pointer temp of node type. I mean, it will hold the node contents into it, address of the node, and this for this, and then we will allocate this part to this empty sorry, this free memory allocation to this temp, right? So that's why we are doing this temp equal to node pointer malloc size of node. We are assigning this temp the address of this freely available space in the memory. Okay, and this freely available space is allocated to temp. Now this temp points to this freely available space. Okay, so this temp will hold the address of this freely available space, that is the size that would be equal to the size of node. Okay, okay, this temp is just a pointer holding the address of the node, holding the address of the memory space equal to the size of the node. Just this. From now from here only we will start checking, like we will put the value, we will put the next as null, and the data as the data that will supply to it. Okay. Now this temp is similar to head. It contains the address of a new node. Okay, this way. So this is the node creation step. This whole, sorry. This whole is the node creation step. Okay. Now there is another step, that is the pointer update step. In this step, what we'll check? We'll check if head equal to null. That is, if there is no node already added to the list, then definitely our head will be pointing to the temp. Okay. Otherwise, else there is some node present in the linked list. So definitely the in the next of the temp we will have the first node address that will be present in the head, and our head will point to the newly created node, that is the temp. Now there is no need of this temp unnecessary pointer pointing to this, so we will make this temp as null. Okay, so this way we can proceed. So this is the basic logic, and then we will can create a new node at the beginning. Okay, I hope this is clear. If not, you can write me in comments section. So that's the end of this lecture. Thank you very much.